Hello, ladies and gentlemen. Thank you for joining me once again. I thought I'd close out my series of talking about hyperbolic geometry, discussing parallel lines. Okay, so we've created a bunch of tools. I even showed you how to make a polygon, the equilateral triangle, for example, and a whole bunch of other things that you can do with regular straight edge and compass can be done in hyperbolic geometry as well. So you might say to yourself, well, other than the lines looking sort of like arcs, what's really different? And I touched on this a little bit when I created, which tool was it? I think it was reflecting point outside the circle. That in hyperbolic geometry, one of the things that distinguishes it from regular geometry, regular Euclidean geometry, you have a line, you have a point, you can get one unique parallel line, a line that's parallel to the given line through that point. But in hyperbolic geometry, this is not the case. You can actually get infinitely many lines. So here we have a given line, and then maybe we have a given point out here. We can create lots of lines. These guys don't touch, so by definition they're parallel. These two here, they don't. This one here does not touch the original line. We can get tons of them going through. It actually creates a very nice looking picture. Now these two do touch. But if I move this guy a little bit, we get a whole range, an infinite number of lines that will not touch. So these are all called parallel lines. Now they're sort of generic. They just happen not to intersect. So I believe the technical term is ultra parallels. When I was reading this, and it was in a very old textbook, they used the term hyperparallels. But the point is, it's just any old parallel line doesn't touch this line. But there's actually two special lines called the parallels. They go through our given point and still don't touch this line, but they're a little more meaningful than just these random ones that don't happen to intersect. So what I'm going to do is we're sort of going to cap this off by creating a brand new tool that creates these sometimes called the parallels or just parallels. So we're gonna create them. Now to do it, well, what do we need? Well, these are going to be very particular lines. They're going to basically get as close to this given line as possible, but they're still not going to intersect in our hyperbolic plane inside our disk. What they are going to do is they're going to intersect this arc right on the disk. And you might remember I talked at one point about points on the circumference of our disk basically act like points at infinity. They're called ideal points, but this is how I think of them, as points at infinity. And in some cases, some people tend to say parallel lines do intersect. Some people say, well, all lines should intersect, but they say parallel lines intersect at a point at infinity. And that's exactly what we're basically going to do, is we're going to construct the ideal points here, and we're going to construct the arc through both that ideal point and this given point, and there's going to be two of them, and these will be our parallels. They won't ever touch our given line inside the disk, but they will meet this line at a point at infinity, which is something these other lines don't do. These guys never intersect, not even at infinity. So in some sense, they're different. They're not quite as unique or special or distinguished. Well, what do we need to do? Well, actually, the first thing we're going to need to do, this is not something we can do with straight edge and compass. Okay, just because the way we made our straight edge tool here. So I'll show you what I mean. We can distinguish the ideal points here. So the points at infinity, the end points of this infinite line, we can make those, but our hyperbolic line tool will not allow us to connect up. Because he was built, if you remember way back when we built the hyperbolic line tool, he was built by taking points inside the circle, having the inversion, so reflecting the point outside the circle, and then we used all those points to create the center of a circle. We got a circular arc out of that. But if your point is on the circumference, you are your own reflection about the circle, and so the way we constructed our tool sort of breaks down. Okay, so we're going to have to sort of fix that. We're going to bring back our inverse point tool. Where is that? There he is. So we're gonna bring it back just for a little bit, because we have to sort of create a brand new tool. Now I think I mentioned, where is that? There he is. There's that rascally inverse point. We'll move him a little bit. But I think I did mention at one point when we were originally doing this sort of stuff that since we're making a circle, we only need the 3 of the points. So we only need one of the inverse points created. Now we just need the circle passing through this inverse point, this given point, and this ideal point, who doesn't have an inverse. So we can still make the circle and thus still make a circular arc, and that's what we're going to do. So I have to bring back some of the other tools, straight edge and compass stuff. So we're going to need perpendicular bisector. Where's that tool? Perpendicular bisector. We'll bring him back just for just making this stuff very quickly. And we need our circle tool. We'll bring him back just for a little bit. Okay. So we'll perpendicular bisector there, and there, and that gets us the center point that we're going to use. Why is the circle orange? That's weird. But yeah. So this now would give us one of the just parallels, and we can make the other one as well. Okay. So now, before I actually go ahead and make a tool out of this, let's hide some of the stuff, and we're just going to zoom in and we're going to talk. We're just going to talk very briefly. So we'll hide our inversion point. But now let's just zoom in. Ignore the fact that these arcs are still extending beyond. We'll fix that in a moment with my least favorite tool, the circular arc tool. But we'll fix that in a moment. But let's just take a look here. These lines, these pink lines, are parallel in that they don't ever touch our green line except at points at infinity. And so they're a little more special. And if I want to create something that is ultra parallel to this line, I just have to pick my other point to be either in this circle or over in this side, just somewhere bounded by these two just parallels. Right, you see, if I take a point that's outside the part of the disk bound by these two, I will get an intersection. So these just parallels are sort of the limiting cases of the ultra parallels, of all parallel lines. Okay? I think that's nifty. We have an infinite number of parallel lines, but there's two very special ones. So now we're going to alter our tools a bit again. Remove the inverse point again. But we'll get that loathsome circular arc tool. We'll bring it back just for a moment. And we are going to got to distinguish these other points here. The two ideal points, and then we're going to draw the circular arc here. So, what color should we make them? Let's go with the bright blue. So, I have gotten rid of the centers here. So let's just quickly bring those centers back. There we go. And I do need this center here. So this center, and then this point, and then we stretch over to this ideal point. This center to this point, and we stretch over here. Alright, so now we can hide our centers again. And we can hide the big pink distracting circles. And we can even hide these ideal points. And now we get the just parallels. These guys are just parallel. And now that I've started using the circular tool, things are going to break down a little bit, whereas it didn't when I kept full circles. But the full circles, I think, are a little distract, and we want to just focus on what's inside the hyperbolic disk. So it's an acceptable sacrifice in my opinion. Okay, so let's create a brand new tool. So we want both of these arcs are going to be our outputs. Our inputs are going to be the lines and the point not on the line. And we need the hyperbolic disk. So we'll call it the just parallels. Sometimes called the parallels. Doesn't particularly matter, but there's our icon for it. And we're done. So now we'll clean up our toolbar a little bit. We'll get rid of the circular arc tool. And the just parallels I'm going to move over. And I'm going to bring back, and they're going to get their own space. There they go. So now they have their own little thing that we can work with. And so that's how we create. So if I have another point, and geez, I hope this works. So the line between these two and this point out here. So we get one of the parallels, and if I move him back, he'll pop back in. Again, it's entirely problems with the circular arc tool. See, I don't even know what this green line that it's making is. Just weird stuff. Alright, so I think that's a fitting way to end this series. We finally created parallel lines. We talked about how there's an infinite number of parallel lines. And once again, the circular arc tool made me look like a fool. So, I think that's great. Hopefully you guys have enjoyed this, and maybe it's even spurred you on to learn about hyperbolic geometry a bit more, and the Poincare disk. This isn't the only one you can do. There's the half-disk model. That's pretty good. It's not my favorite. I like everything contained in the disk. But that's just because that's how I was originally taught. But, yeah. Go out, study hyperbolic geometry on your own, study elliptical geometry, study absolute geometry. Oh, there's tons of fun stuff you can do. And, you know, most of them have a version of Straightedge and compass. And so you can see what carries over, what parts of Euclid's elements continue to exist in all of geometry, and that's something called absolute or neutral geometry. And it's very interesting stuff. But I think that's it for me in this series. Thank you as always for watching, and I'll see you in the next video, whatever that may be.